Okay, in this video extra, I'm just going to go over a couple more problems where we are checking the conditions. So these problems are about means. And this first problem says, let's see. A safety specialist was concerned about car speeds on a certain busy stretch of road. They randomly selected 21 cars and measured their speeds at the same point in the road. Each car was different from a time period and day, so the specialist is willing to consider the sample as representative. The speeds in the sample were strongly skewed left with a sample mean of x bar equals 96.5. There were also a few outliers. The specialist is considering using their data to make a confidence interval for mean speed. So we need to determine which conditions have been met. So number one, the random condition. So they do say randomly selected, so that one is good. The sampling distribution is approximately normal. So remember, there are three different ways we can meet this. Our sample can be big, meaning greater than or equal to 30. Well, in this case, we have 21 cars. That is not greater than or equal to 30. So we're not meeting it that way. The original distribution is normal. It doesn't say anything about the original distribution being normal. So for it being normal, that's not true. And then the last way, it says if we look at our sample and the data is roughly symmetric, then in that case, we can also meet that condition. Well, in this problem, they tell us it's strongly skewed to the left, and in fact, there's also outliers. So in that case, we can't say that the sampling distribution is approximately normal, so that condition is not met. Lastly, individual observations can be considered independent, so this is the 10% rule. In this case, we don't know how many cars in the population, but we know that there are a lot of cars that exist in the world. So if they're randomly selecting 21 cars, it is reasonable to assume that 21 is less than 10% of the population of all cars. So that's reasonable to assume, which I'm just going to abbreviate RTA. So that condition is met. All right, here's another type of problem. They give us a couple dot plots of two different samples from two different populations. The first sample was a sample size of 13. The second one was a sample size of 34. We want to know which sample satisfies a normal condition. Well, we know that if we have a small sample, if our distribution, our sample is roughly symmetric, we can consider it to be normal. That condition can be considered met. But in this case, since our sample is small and this is a skewed left distribution, we know that this does not meet the normal condition. Checking sample B, this one is also slightly skewed left. However, since our sample size is greater than 30, it does meet the normal condition. So in that case, sample B is going to be the answer for this one. Okay, last one, similar to the first one. Zachary wondered how many text messages he sent on a daily basis over the past 4 years. He took a simple random sample of 50 days, so that's N, from that time period, and found that he sent a daily average of 22.5 text messages. It says the number of texts in the sample were strongly skewed to the right with many outliers. He's considering using his data to make a confidence interval. So number one, random sample, yes, it says SRS, so that condition is met. Sampling distribution is approximately normal. Well, since N was 50, 50 is greater than or equal to 30, so that condition is met. So even though it says that his sample was strongly skewed right, his sample is large enough that it would meet that condition. Then it says individual observations can be considered independent. Well, if you think of all the text messages that he's ever sent in his whole life, it is reasonable to assume that he sent text messages in greater than 500 days. So where 500 came from, 50 is 10% of 500. So it is reasonable to assume that 50 is less than 10% of the population. So this last condition can sometimes be a little bit difficult because a lot of times you're not given a number for the population. Majority of the time you have to consider if it's reasonable to assume. If they don't give you a number, that's probably because the number is so large that they can't give it to you. So it's usually safe to assume that this condition is met. Rarely will I ever give you a case where this condition is not met.